I've looked at clouds from both sides now, from private and hybrid and public somehow. It's clouds illusions I recall. All right, so in this nugget, I'd like to chat with you for a little bit about cloud computing, what it is, some of the additional security concerns we have regarding it, and also some of the benefits from a security perspective about using and why we'd want to use cloud computing. A story that can help us better understand cloud computing is to imagine a couple of people who are going to start their own business and they want to have a storefront. Now, they could go out and purchase a building and then furnish that building, set up all the utilities in their name, and start their storefront that way. But there's a huge initial overhead in doing that regarding cost and effort. Or they could work with a property manager that already has a building in place, and they could rent a subsection or possibly even just a small corner office out of a larger building that's already furnished, and they could simply pay a fraction of the price than they would for the whole building and still have most of the services that they need. And so that begs the question, okay, Keith, how is that like cloud computing? Well, if a company wants to have their own data center on-premise, and let's use this portion of our network just as an example. If they're doing it on-premise at their location, they first of all have to buy the equipment. There may be one or two or many racks of gear, and that gear is going to include CPUs, memory, networking. There's going to be climate control inside that data center or inside that facility. There's going to be power management, which should include things like uninterruptible power supplies and fault-tolerant power. There's also the space that's required for that gear. There's also the people required to manage that space and manage that gear. They probably have support contracts on the hardware. They also have licensing. I'm having a little spelling issue today. They also have licensing regarding the operating systems and the apps they're running. They also have maintenance on those devices, both preventive maintenance for the physical equipment as well as software maintenance with updates and patches and so forth. And if they're doing it on premises with their own gear, all of that is the burden of the company that's implementing those solutions. So with cloud computing, if a service provider came in and said, you know what, we'll not only host all of your devices and all of your services, but we'll also do a lot of the management of it as well, so that you can focus on your business and we'll focus on the management and disaster recovery. And what we'll do is we'll simply have you pay for it. The provider says to the company, we'll simply have you pay for it as a commodity. So if you use a lot of resources, you can pay a little more. If you're using a very little bit of resources, you can pay less. And the reason that a lot of this is possible is due to something called a hypervisor. And with a hypervisor, we can take a platform that physically has multiple CPUs and memory and other resources, and then on that physical platform run a hypervisor. And then within that hypervisor, we can have multiple virtual machines. So we get a VM1, VM2, VM3, etc. So with a service provider using hypervisor technology, there's lots of benefits. Some of those benefits include self-service. And by self-service, what I mean is the customer can log on through their portal to the service provider, and without another human intervention at the service provider, the user can go ahead and request additional resources. Maybe they need another server, or perhaps they want more instances of a server, or more CPU, or more memory, or more bandwidth. They can order that through a self-service portal, and they can spin those extra resources up in just moments. So that makes it really easy for the customer to order and get the services that they need and want. The second benefit is that these are measured. And one of the benefits of having measured services is that the company can just pay for what they want and what they use. So for example, if they have a website that's offering some type of a product and there's a huge surge, the service provider, based on the requirements of the customer, can automatically expand and increase the resources allocated for that customer on demand. And that's referred to as elasticity, the ability to grow. And now the customer can control what they're willing to grow up to and some parameters regarding how far to go. And that is a really cool feature. The customer, like a utility or a commodity, can simply pay for what they used. Another benefit is the pooling of resources. And if it's a public cloud provider, that's a benefit for the provider because they can maximize the resources they have. For example, if they have 1,000 physical units and 200 of them are less utilized than the others, they can move some of the load to those less utilized physical systems and not waste physical resources that they have in their environment. And another major advantage of cloud computing is network access. And that also goes along with self-service. So for example, a customer who has a browser and a credit card, they can use self-service using the existing network access over the internet to provision and bring up the resources that they want to rent, if you will, through cloud services. Now, cloud services are not always provided by some other service provider in the cloud. For example, this company, if they wanted to have their own private cloud, they could do that. You could have your own private cloud on-premise. So this company could use a product, for example, on-premise like VMware with vSphere, and have their own virtualized environment that's for their own private use, and that could be referred to as a private cloud. As we go out to the internet and we look at additional providers out there regarding cloud services, we've got companies like Microsoft, Amazon, and Google, who are major players in offering cloud-based services. They're not the only ones, but they're the big heavy hitters. So if a customer is doing it internally or having the hardware allocated just for them, that could be referred to as private cloud. If we're using fully the services of a public cloud provider like one of these, where the same hardware is used for multi-tenancy. For example, this company may have a slice of this computer or this computing resource, and another company may also share the same physical hardware, but be in a totally different virtualized space. That multi-tenant provider model, which is available over the internet, could be referred to as public cloud services. And if a customer wanted to have their own cloud, for example, a private cloud, and then for overflow purposes, maybe extend into public cloud for additional resources above and beyond what they have locally, that could be referred to as hybrid cloud. Now, regarding the types of services, there's a concept called EaaS, which is everything as a service. I've also seen it with XaaS, again, where that first letter is representing a variable. And although there's many different types of services, there's three that I'd like to point out right now. And the first is called infrastructure as a service. So if we use this rectangle right here to represent everything the customer is using, let's say these bottom two layers involve storage and some of the back-end networking that provide the underlying connectivity from a networking perspective. And also down here we have some virtualization software, making it all possible. And Microsoft and Amazon and Google have their own methods of doing virtualization, and VMware has their own way of providing the virtualization with their hypervisor. But with infrastructure as a service, we can spin up whole VMs. So I'm going to draw a line right here, and with infrastructure as a service, we would have the operating system that we can play with, which also would imply that the customer who's renting infrastructure as a service is responsible for patches and maintenance of that operating system. Of course, any apps that are running on that operating system would also be within the control and responsibility of the customer who's renting that service. So an example is we go out to Amazon Web Services, we say we need 2 Windows 2016 servers with this much memory and this much storage, and they get spun up. And then we have those operating systems to work with. And then what we do with those operating systems, what applications we load on top of it, etc., are up to us, because we're renting effectively these virtual machines in the cloud. Now, what if there's a company that's developing their own applications and they want to focus on a platform for development of those applications? They don't want to be responsible for the entire virtual machine. They could go ahead and use PaaS, which is platform as a service. And so with platform as a service, for example, I'm going to draw a line right here to represent the demarcation between what the customer is in control of and what the provider is in control of. So with platform as a service, the operating system and everything below this green line would be maintained and managed by the cloud provider, while the apps and the other development platform tools would then be the responsibility of the customer who is renting platform as a service. Think of platform as a platform for development of applications. And then as we continue to go up, what if we had a system where everything is managed by the cloud provider and the customer is simply using the software, using the application? And that can be referred to as SaaS, or software as a service. An example of that would be Salesforce, or some other application where the user is simply the customer. They log in, they use the service, they use the apps, but they don't have to worry anything about the application itself regarding patches or updates or maintenance. All of that, in this example, below the black line here, is the responsibility of the provider who's providing the software as a service. So that, my friend, is a definition and a little overview regarding cloud services and cloud computing. Now, we do have some concerns regarding applications and cloud-based computing. And those concerns are the same concerns as if we were creating and developing and hosting our own applications. For example, what we've learned from OWASP, along with the Broken Web Application Project, we still need to be concerned with our applications with problems such as cross-site scripting, SQL injection, session hijacking, and all the rest. So those concerns all still exist. And some additional challenges that we have are, where's the data? Because if we're storing it in the cloud from a service provider, are those bits residing in your same country, or are they being stored in a data center somewhere else? And for fault tolerance, it's very likely as part of our DR plan, we want to have the data stored in different locations. Now, if it's too geographic where we have some in other foreign countries and some here, that could be a problem because are there different rules regarding the sensitivity and access to that data? And the answer is yes, there are different rules based on where that data is stored. So from a security perspective, we want to know where that data is being stored and also know what the rules are regarding that location. Some governments intentionally track data that goes outside their borders that may give them more access to eavesdrop or look in on that data because they're doing it as that data is outside the geographical boundaries of the country that they're in. So we'd want to be careful about where the data sits. That's a new concern with cloud computing. Another issue is compliance. If we're storing data in the cloud and we have to comply with things like PCI or HIPAA or other regulations that govern the business that we're doing, is the provider that we're storing that data with helping us or hindering us with meeting those requirements? So compliance is now going to be an additional exercise because we're not hosting and storing the data ourselves. It's being hosted and stored by a provider in the cloud. Another concern is what if? And you might say, Keith, what do you mean, what if? Well, what if the service provider goes out of business? Or what if the service provider gets acquired by somebody else? Or what if the service provider has a radically different change in the way they charge for services? And hopefully, regarding pricing, a contract with guaranteed rates for a period of time could help with that part. But a concern that we should have is, are we going to be locked into this provider? And do we have options if we need to move somewhere else? And in the case of operational expenses, if our cost went from X and then all of a sudden it got changed to 10X, of course that's a significant impact that hopefully the company would be prepared for or able to move away from that service provider in the event that happened. Now, most of the time for cloud services, the price continues to go down, down, down. And the cloud providers are working to be more and more competitive and have more and more services. So that is something that we'd want to go ahead and consider as part of cloud computing. Now, cloud computing can be a double-edged sword because it's so darn convenient. In fact, it's so convenient that we could have individuals in our company that go out to cloud services and spin up or use cloud services that are hosting company information without going through the IT group or the security group. And that's referred to as shadow or sometimes stealth IT. And I think a lot of people, including myself, have been guilty of this at one time or another. For example, a business unit goes to IT and said, I need XYZ, and they say, okay, that'll take a week, or that'll take a month, or we need to get more details. And the person in the company who requested the services says, you know what? I could spin up my own server in 60 seconds with Amazon Web Services or with Azure. And then they go behind the back of IT, they simply do it. And now there's an additional attack vector that has the data from this pocket who's rented cloud services that's hosting company-sensitive information. Another new concern is the admin portal. So as an example, let's say this company is renting IaaS, infrastructure as a service, and they've got 20 or 30 servers that are spun up and running with various amounts of CPUs and memory and access to storage. Well, if there's one admin portal for all of that, if that gets hacked or attacked, and an unauthorized user can go in there, the unauthorized user could do all sorts of damage. For example, they could spin up additional servers or increase the CPUs or the memory that's available or the bandwidth that's available on the existing services, and then start additional services that are going to start chewing up those resources. For example, if somebody is doing Bitcoin mining or the calculations for any number of other type of cryptocurrency that's out there, the more CPU you have and the type of CPU you have controls how many hashes you can generate. So if a hacker compromises the admin portal and then says, okay, we can have 20 instances, we can have all these processors, and then they start running on those servers, Bitcoin mining, the company that's renting those services are going to get the bill. So it could be in the tens or hundreds of thousands of dollars, depending on how many servers the hacker brought up and how much CPU and resources that the attacker was able to go ahead and use on those virtualized environments. So then if the cost is normally X and it just went to 10X because of the hacker getting in and using additional resources, that could cause an EDOS, which stands for an economic denial of sustainability. Now, likely it wouldn't go on too long because whoever gets the bill is going to say, holy shnikers, why is our bill $200,000 this month? And they would go in and very likely correct that. So it'd be very important to protect the admin portal. There also could be bugs or flaws in the hypervisor itself. So with the public cloud, because we have multi-tenancy, where we could have 15 or 100 different customers all using a slice, if you will, of one physical system, if there's a bug in the hypervisor or if there's any type of interaction that's inadvertently allowed between virtual machines or between the memory or the disk allocated for virtual machines, if the bug is discovered and then compromised, the potential exists for every virtual machine on that one physical platform to be compromised based on the bug or flaw in the hypervisor that should be providing the isolation. And the last thing I'd like to mention here is ease. Now, I put ease here on the list of concerns because if it's easy for an end user to purchase and spin up a whole server in like a minute, it's also easy for an attacker to spin up a server or multiple servers in under a minute and then use those for malicious purposes. Maybe the attacker needs a whole bunch of resources for a password cracking utility. Or the hacker wants to have a command and control network for their botnet and they want to have some fault tolerance, so they have multiple servers that they can spin up very, very quickly in the event one of their existing command and control servers is discovered and taken down. So these are a few additional concerns that we have when we're dealing and working with cloud computing. Now, regarding some of the benefits that we have security-wise from cloud computing. Number one, we can absorb an attack probably better with cloud computing as a service provider, better than we could if we were hosting the environment on our own premise. And that's because the providers like Amazon and Microsoft and Google, they've got some pretty hefty infrastructure and some controls in place, which also are very likely to include awareness of attacks against their infrastructure so they can go ahead and not be completely beaten down by a distributed denial of service attack. And if there is an attack against this company, which is now using cloud services, there's also on demand from many of the vendors the ability to scale up, which means, for example, more CPU or more bandwidth per system, as well as scale out, which could include more servers. So if there's a distributed denial of service attack and we want to survive it, we can go ahead and temporarily crank up the resources through the admin portal until we get a grip on solving the distributed DOS attack. And it may cost us a little more because we're going to be using additional resources while we're under attack. But if we can stay in business and stay up, that's an awesome benefit and worth the cost of the additional resources for that short period of time. Another benefit that I mentioned, I also want to list it here, is that the cloud providers probably have quite a bit of experience with DDoS already as far as how to protect against it. And some providers have services specifically for DDoS that you can add on top of it. So for an extra fee, you can purchase some additional services. Or if the provider you're using doesn't have it, there's also options for third-party cloud services that could be used for analyzing and inspecting traffic before it gets to your servers. So if we want to purchase the services of an intrusion detection system or a web application firewall or email filtering, for example, most of those are available as cloud services that we can purchase and route through before we have that traffic hit our production systems. Which means instead of having to purchase a $10,000 appliance, or maybe two of them if we want fault tolerance, for our own internal infrastructure, we can purchase the services of that type of a system from the cloud provider as a service, paying as we go, as opposed to spending the tens of thousands of dollars upfront for the dedicated appliance. Another benefit regarding cloud computing and security is human resources. And that's because the cloud provider, let's say we're doing platform as a service or software as a service, they've got the expertise. Whether it's Amazon or Microsoft or Google, they've got the expertise regarding how to maintain and operate their internal systems. So this company over here, because they're not hosting all the gear locally, they don't have to have their own data center and their own people who are experts in the administration and support of the platform. And because one of the biggest costs in IT is the human resource aspect, we can allow the cloud provider to take the brunt of that hit, and then all we do is purchase the services as a commodity. And that helps the company avoid a whole bunch of problems, such as inexperienced or underskilled or individuals that are not security conscious, because the service providers who are doing the cloud services that want to stay in business, they have hired the right people with the right skill set, or at least that's the intent, which removes that burden from this customer. Another cool benefit with cloud services is that there's normally RBAC, which is an acronym for Role-Based Access Control. And what that effectively means is that through the admin console, we can set up multiple users and give them limited rights, using the concept of least privilege so that the user has the ability to do their job, but not more. For example, Bob, the user, may be given access to log into the admin portal for the cloud provider and have read-only access to one or two sites. But at the same time, he doesn't have King Kong rights or owner rights to everything. And by isolating what a user is able to do, we're also limiting the risk of the damage that user can cause, either through a misconfiguration or an exfiltration or a stealing of the data. And that data could include keys and passwords and other sensitive information that might be stored or accessible through the admin portal. It would also control things like not allowing Bob to simply spin up additional resources or to scale out their infrastructure without the proper permissions. And for more on role-based access control, and for formulas regarding risk, you might want to check out our CISSP course, and I've got nuggets specifically on those topics. So that's a great additional resource that's part of your CBT Nuggets membership. Another benefit is virtualized networking. So if we need to set the equivalent of VLANs, protected subnets, that are only accessible by certain virtual machines that can interact and communicate with each other, we can set up switching and routing and other network services so that the customer, with just a few clicks, can manage and set up their networking for the virtual machines that they're purchasing as a service from the cloud provider. Another huge benefit with cloud services is the auditing capacity. That's tracking everything that's being done, so you can have a third-party auditor come in, give them access to those auditing records. So when auditing needs to take place, because it's all based on cloud services, the auditor doesn't have to say, okay, I need the log files from this system and that system, the other system, through the admin portal. So it's easier for an auditor to actually go through and see what's going on or what has happened for the cloud-based infrastructure. Another cool security benefit is that most admin portals for cloud services allow multi-factor authentication. So with authentication, there's 3 factors. There's something that the person has, for example, a token, or a card with a chip on it that has a digital certificate. That's one factor. There's something that the person is, which is all about biometrics, for example, a thumbprint, a retina scan, etc., and something that the person knows. The most common example of that is a password. And with multi-factor authentication, which is often called two-step authentication, we're going to use at least 2 of these. So for example, maybe something that the user has, like a token that was generated, and that can be done with Google Authenticator, or maybe it's some kind of a message or a string of text that was sent to the user in some other method. One common method that has been used in the past is an SMS or a text message that's going to give that user a code, although that's going to rely on the confidentiality of the telephone system. So perhaps SMS and texting is not the best method for one of the factors of authentication. And usually the other option is something that the user knows, like a password. So when the user authenticates, they'll have to put in a username, the password, as well as a token or a string of text or some other information that they just received as a second method of verifying that that's really the user who's authorized. Another security benefit is that it's often easy with cloud-based services to turn off features or functions that are not needed. For example, if we're doing platform as a service and we're not using Java, we can simply click a button that says we don't want that service available on this website. And so by reducing the services or features that aren't needed, we're also reducing the attack vector for that site. Another benefit that I touched on earlier is disaster recovery. And although we want to know where the data is stored, it's really handy to be able to tell our service provider that we want the data stored in 2 or 3 different locations, and we can control or specify where we want that stored. So if we want it all stored inside of our own country, whatever country that might be for you, you can specify that and have fault tolerance regarding the data, and also keep it inside of the geographical area that you need to or want to based on your policies. Another cool benefit is VPN services. So whether we're moving data over to our public cloud services, or if we have a hybrid where we have a private cloud and a public cloud and we want to move data between them, using VPN services allows us to encrypt the communication channel from end to end. And that's going to help us with a couple of things, including data integrity as well as confidentiality, which is provided because we're doing encryption as part of the virtual private network. In this nugget, we've taken a look at cloud computing, along with some of the security concerns that are new to cloud computing, as well as some of the benefits that cloud computing can provide for us. So I'm glad you joined me in this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.